Welcome back to Science Modernizers. Today we are going to see the class block experiment. So we are going to have a brief procedure and a brief way on how to conduct this experiment in the physics laboratory, that is physics paper 3. So let's get started with the requirements. To begin with, we have the requirements. We have a drawing board, about 8 optical pins, white sheet of paper, a rectangular glass block, a protractor, pencil and thumb pins. We have the procedure. So we are going to do the procedure all together with the diagram to see how we are supposed to draw and to conduct the experiment. We are going to see how to collect data as a station and also how to collect data as a mainstream. So the first, we are going to fix a white sheet of paper. In other words, we are going to fix a sheet on a cardboard using thumb pins. So thumb pins are simply pins which we can use to fix papers on a given surface. So we are going to begin by we are going to consider our screen, that's our empty screen, as our sheet of paper. Then we are going to imagine that it's on a cardboard. Yes, on a cardboard. So the next is we are going to place a glass block on this at the center of the white paper and draw its outline boundaries using a sharp pencil. So you just need enough space for you to do the experiment on the white sheet of paper. So that is my glass block, and we are going to make the outline of the glass block in black. Now the next step says let ABCD be the rectangular figure obtained by drawing. So we have that the edges might not be necessarily smooth for your diagram, so the edges might not be actually sharp like this, but you might have something like this, so there's no problem. So we are going to label our rectangle ABCD. Now we proceed. The next step says we should mark a point E on AB and draw a perpendicular EN and label it as the normal ray. So that is a point marked E and it is on the face AB. Then we draw a perpendicular using a ruler, and then we call N. So that's our normal. We call it N. That's the line EN in total is our normal. Now the next is we should draw one angle of 25 degrees with the help of a protractor with EN. Now we are going to fix pins P1 and P2 maybe 4 to 5 centimeters away from each other to obtained by measuring the angle. Now in this, you have to note that when you are dealing with a mainstream, you are going to be given a procedure like this in order for you to follow, and then you have to vary the angle of incidence. So typically we can vary an angle of incidence, let's say I. We can take it from 25 degrees even to 70 degrees. So you can take it in intervals of 5s and have a minimum of 8 value. So a minimal value should be 8 values in order for you to have a good experiment. So remember, the glass block experiment is mostly used in the determination of the refractive index of the glass block itself. What is refractive index? Is it simply the amount of how much the speed of light will vary from air and when it passes through a medium. So in our case, here we have air and here we have our medium, which is glass. So it means that when air is going to, when a light ray will pass, when light rays will traverse the glass, something will happen which is known as refraction. So we are going to have a bending of the light rays at a certain angle, which is going to alter the speed of the light inside the medium. So let's continue. We are going to draw an angle of 25 degrees using a protractor with EN. So remember, you are measuring EN, you are measuring the angle with respect to the normal, not with respect to the base AB. So you place your protractor and we find the angle marked 25 degrees. So we see from here, we have 0. This is our 0 mark. You see how the protractor is placed. The 0 mark is at the center point. So the center point is on our point of reference where we are measuring our angle. Now the line, this 0 line, gets lost at the level of the line. So you place it well and you measure this 180. In other words, 0 degrees. We have 0, 10, 20, 30. So 25 degrees will be this middle part. So we mark it. with something. You can use a single dot on your paper. You don't need to make big dots. So I'm doing those circles for the sake of visibility in the video. So you can simply use a dot on the place, on the point, and you link later on. Now let's go to the next. Now we have placed our point pins P1 and P2 along that line, so it should not be different from the line, it should be along the line. Then we link the points. That's the first thing we have to do. Now let's proceed. Now we are going to place the glass block back in the figure, or in our rectangle that we drew. So after removing the glass block, now we are going to place it back with our 2 pins on position. Do not shake the pins and do not shake anything while doing this particular step, because any alternation which you do is going to affect your result dangerously. So as your paper is fixed, insert your glass block gradually into the outlines which you have drawn. So that is my glass block which has been inserted. Now what do? We are going to stand on the face CD. Now we are going to want now to fix our other pins, that's pin 3 and pin 4. So what do? We have to see through the face CD. Now you come, while these 2 pins are standing where they are initially, you come on this other side, you start looking at this interface between CD. You place your eyes, so your eyes should be somewhere here. So you should be looking at what is happening. Now you have to place your pins in such a way that when you look at these other 2 pins, what you should observe is a straight line. It means this should be on seem to be in a straight line with the pins which you are supposed to place. So in other words, when you locate how the pins are actually straight, it means you are going to see how one is exactly like this, and the placement of your pin should not be somewhere like this. It should seem as if all of them were aligned, so it should be on a line like this. So you are definitely going to see such a point if you observe very well. So be very attentive when you are doing this, and make sure that you take your time in doing such. Now what do we have? Now while placing your eyes here, you move your eyes through the interface CD or to the face CD in order for you to see where you can place your pins P3 and P4 on that line. So as I said, it should lie in a straight line. So if you don't see, if your pins are not on a straight line, don't pin it. So what do we have? We are going to observe something like this. So on this side here, this position which I've placed my pins will seem, when I'm looking on this interface, that this is aligned with these 2 pins. That's the aim. But when you will remove your eyes and check what you have done here, you will realize that they are not necessarily aligned. They are not aligned. So it doesn't matter. So the alignment should be when you look into the glass block, not when you lift your head to see what you have done. Okay. So now draw small circles around the pins P1, P2, P3 and P4 and remove the pins. So this is just to mark the position of the pins. Then what else? I've marked my pins P3, P4. We can now remove the glass peacefully so that we can draw our outlines. So we can remove the glass block. Now the next is we are going to join P3 and P4 such that it meets CD at the point F. Now we are going to draw a perpendicular, that's N prime E prime, to CD at point F. Remember, CD is the interface down, it's this interface. Okay, so let's do that. That's our normal, and that's our point F. So that's N prime E prime. So we have our pins P3 and P4. So we are going to link them with a straight line. What next? The next thing we do is we use a pencil and we link or join the point E and point F. So point E and point F. Now we are going to link them. So you use a ruler, straight line, you link them. So that's what we have. So you see how the setup is coming out. So when you will be looking at the interface, these lines should seem as if they were in a straight line. So it should be something like this. You see your pins here, see the other pin you're pinning, then with this other two. So it should be aligned with those two. So don't forget. Okay, so the next thing we do is we measure the angle formed at AB and CD, that is the incident angle, refracted angle, and the emergent angle. Now the emergent angle, after measurement, you will realize that this emergent angle will be the same as the incident angle, but our incident angle was 25 degrees, so here too we should have 25 degrees upon measurement. So you can measure and you verify. Now let's measure the angle of refraction, or the refracted angle. So we place our protractor and we read. So we are measuring with respect to the normal n. So here we come, we have 0, then this 15, it should be at about 17. So we'll call this, it's in between 16 and 17, so we'll call it 17 degrees. So we note it, R is 17 degrees. So let's now see how to deal with this as a station. Now as a station, remember, a station means you are collecting just one value, whereas a mainstream means you are collecting several values. Okay, so that's what we have. Let's pass to the phase of the calculations. So as a station, what do we do? As a station, we know that the refractive index theta is sine I over sine R. So from our diagram, we can simply have, since we know that the angle of incidence is 25 degrees and the angle of refraction is 17 degrees, so we can calculate theta and it will give us 1.45. And note, the refractive index of glass is normally 1.5. So you see, we are close to actually the actual result, and we cannot be perfect since we are not machines. Now the next is, we can conclude there that the refractive index of the glass block is 1.45. Now let's now see it as a mainstream. So if it is as a mainstream, instructions will be given for you to follow, and maybe you might even be required to measure some respective distances between the rays which are formed. But in this case, if you simply want to measure the refractive index using Snell's law, then all we need is the angle of incidence and refraction. So we are going to vary it and so on and so forth. So as I said, we can take the angle of incidence I to be between 25 degrees and anything of your choice, like 65 degrees, 70 degrees, no problem. Don't take it up to 90. So you see, we can take it in intervals of 5, 25, 30, 35, 40, 45, 50. Then we construct a table of values. So remember, your table of values should be very neat. So our table of values will be as such. So we are going to have I in degrees, R in degrees, sine I and sine R. So for the case of our 25 which we measured, our R was 17 and our sine I will give you 0.42 and sine I 0.42 and sine R 0.29. So this is just the sample of the 25 degrees. So you do the same for 30 degrees, 35 degrees. You repeat the experiment and you vary the angles. So you vary the angles and you are going to have different outcomes, different outcomes, and so on and so forth. Okay, so that is how you treat it as a mainstream. Now when that is done, you are going to plot the graph that is required of you there. So they will always give you instructions on what to plot, but since here we are determining the refractive index using Snell's law, we can plot the graph of sine I against sine R. And also remember, you can also be asked to plot the graph of sine R against sine I, so that when you calculate your gradient would simply be 1 divided by the refractive index theta. So you have to be very careful, and notice that the refractive index of a medium should never be less than 1. So if you have a refractive index which is less than 1, it means you are wrong, because from definition, the refractive index is the measure of the speed of light in vacuum divided by the speed of light in the medium, and there is nothing which is faster than the speed of light. So C is greater than V. So this therefore implies that theta should always be greater than 1. So you have to be very careful when it concerns the refractive index. If you calculate the refractive index, be it in physics paper 1 or paper 2, paper 3, and your answer is less than 1, no, you have already gotten it wrong. So you can mark your paper before you leave the hall. So when you plot the graph of sine I against sine R, you have a straight line graph as such, and you simply calculate your gradient. You could consider 2 points. Triangle is not the best, so you extrapolate these points, extrapolate these points, extrapolate these points, extrapolate these points. So imagine we had 0.8 minus 0.4, divided by 0.62 minus 0.3. So that's a possibility. So if we assume we had 0.8 minus 0.4 divided by 0.62 minus 0. Maybe 0.3, so it gives us like 1.25. But anyways, you do it very well on your sheet. So that's what we have. So the gradient here, sine I over sine r, gives you neta. So that's what we have. So as precautions, the rectangular glass blocks should have perfectly smooth faces. The drawing board should be soft. All pins base should be in a straight line. Use sharp pencils and so on and so forth. So those are precautions that you can take. So thank you very much for watching the video. Simo 413 is our YouTube channel name. So please, thanks for watching, and do not forget to like, share and subscribe. See you in the next video. I was kind of in this.